Hello and welcome to this new tutorial. In the previous video, we worked on our widget to display user account information. Also, we created the player card. Today, we will continue our work to discover what we can also do with the plugin concerning the user account. Remember, these features require an authenticated user, otherwise nothing will be displayed in the widget. Look at the plugin log and see the errors. Go back to the Player Info folder, then open the Player Info widget. We will add a button to log out the user. Note, the logout process is not supported on all platforms. In our case of EOS, it is supported. Add a button to log out the user when clicked. Select the button, then scroll down to add on clicked event. Call the function of Easy OSS, logout player from OSS. Show the error message if the task fails. If the task completes, I will do nothing but display a message on the screen. Now, test your implementation. As you see, the logout was executed successfully. If you log out again, you will have an error message informing you that the user is not logged in. Return to your game instance. It depends on your target platform. A delegate will be fired when the login status changes. Remember, to use the OSS delegates, the function init all OSS delegates handles must be called first. In Easy OSS category, then in Game Instance, Events, Account, you must have all the delegates that you can bind. Click on Assigned Login Change. You will see an event bound to this delegate. This delegate fires when the user authentication changes. It is up to you to decide what to do in this case. Do the same thing to assign on login status change. This delegate fires if the login status changes. The first event provides a message informing that the login has been changed. The second provides the old status and the new status with the concerned user ID. The status is an enum of 3 values, not logged in, using local profile and logged in. For this event, I will display for now a string containing the old status and the new status. Then I will launch a test to show you this message when we click on Logout or on Login. For this event, I will display the message provided. Test your implementation. As you see, this event is not supported on EOS subsystem. We will test the second one. Here, a message is displayed indicating that the old status is not logged in, while the new one is logged in. When we click on Logout, we will see an inverse message. Here, this delegate can be triggered if the user clicks on Logout, or by the OSS without user action, for example when his token expires. We notice that the user info is still displayed while the user is logged out. This is normal, because this info comes from the game instance which stored the info when the user was logged in. Finally, it's not a problem, because we will force the user to leave the lobby in case of logout. Before making a decision on this event, I will show you how to bind this event in another blueprint than the game instance. Now I will make a condition. If the new status is different than logged in, then I will open the startup level, so the user is prompted to log in again. I will now test the implementation. Here, as you see, when this condition happens, the user is redirected to the startup level to log in again. We will not trust the delegate only to redirect the user. We will open the level also if the task logout completes. A new test to be sure of our implementation. Another question to ask regarding user account: how can local player interact with other users? Well, the online interfaces of Unreal Engine do not provide us with any functionality to get the info of another player. On the other hand, they provide a friends interface. It allows us to have the information of our friends. We will see that later. On the other hand, to find a non-friend player, each OSS has its external UI, which allows us to search for players. For example, in case of EOS, press Shift plus F3, the social overlay opens, and from there you can search for players and add them to the friends list. Excuse me, the social overlay for me is in French. It depends on the country where I am. Now you will see that player 2 has received an invitation from player 1. We will see all this in detail in the Friends section later. Now I will implement the logic when user clicks Quit Game. Select the Quit Game button, then add the on-clicked event. You can add a logout before quitting the game, but according to our implementation, the game does not close, because the user redirection to the startup level prevents the game from closing. I show you. A function similar to Quit Game, Easy OSS provides you request engine exit function. You can use it if you want. Test the implementation. You will see that the delegate will prevent the game from closing. Because it will open the level startup, this action prevents the Quit Game function from running. Here, the level is open, instead of the game closing. I deleted the logout task. I call the Quit Game directly. Anyway, the logout is not important. It is important when it is requested by the user, for example, when he does it to change accounts. Run a new test, and check that the game closes correctly. This is what needed to be demonstrated. Now we will display the player name above the character mesh. This allows us to identify the character of each player when we have a lobby with guests. To do this, go to your character's blueprint and open it. Click on the Add button, then add a widget. Then change its location in a way to put it above the mesh head. Change the space to be screen instead of world. This widget must have a widget class. It will be a normal user widget. The latter must contain the name of the player. Create a folder, then create a widget in it and open it. This is simple widget. It should contain player name only. Follow me to do it. Now we need to create a custom event, which is used to update the text when it is called. Return to the character blueprint. With the widget selected, we must change its class to put it to the widget that we just created. You can also play with the draw size to change the size on screen. Run a test in the editor to check the result. Now I will update the text of the widget in the begin play of the character. From the widget, call the node getWidget. This returns the widget that we created and assigned as class for the character widget. Cast it to the created widget. Call the custom event of the widget we created to update the text. Since the character is spawned from the lobby game mode, the player name to pass to the widget must be done from the game mode at the time of the spawn actor from class. To do this, create a string type variable representing the text and then make it editable and expose on spawn. Then connect it to the custom event input. Return to the lobby game mode, on post login, search for the node spawn actor from class, then refresh it to display the new exposed variable. For a quick test, give any value to this variable, then run level to check the implementation. There you go, everything works fine. Now, we will automate the script. We will find the name of the player joining the lobby automatically. To do this, we must work with the OnPost login controller. Open the lobby player controller. We must find the player card from the game instance and provide the information to the game mode. Very important, the game instance is a client-only or server-only object. When the lobby host invites players, his game instance will be game instance server-side for guests. For this, the player controller must provide the information of the game instance client-side to the game mode, which is the server. Create a custom event to run on client and name it client_setGameInstance. Also, another custom event to run on server only with name server_setGameInstance. Get the game instance on the client event, then provide it to the event running on server. Like this, when game mode accesses the player controller's game instance variable, it will have the reference of the client-side game instance, which contains the client's player card. In the begin play event, call the client_setGameInstance event. Now I'm going to access the player controller's game instance variable via a simple cast, and then get the player card. Run a test on an authenticated user. You see that it didn't work. I'll tell you the reason. The event on post login doesn't mean that the player controller has finished executing the begin play. So what was happening there on post login accessed a null game instance. If you put a short delay, then you will see that it works. Run the test again. There you go, everything works fine. On the other hand, we will not trust the delay, because we do not know how much time the player controller needs to finish the execution of the begin play. For that, we will use another solution. The solution is to not spawn the actor once the post login fires. Instead, What we will do on the onPost login is to increment the number of players only. We will then use another way to spawn character. We must verify that the player controller is ready first. Follow me to understand what I mean. Create a variable of type controller and make it a list. It will be a list of all the controllers that are part of our lobby. On Post Login, add the new controller to this list. Return to the player controller, create a bool type variable, and name it is player controller ready. This variable will indicate when the player controller is ready. Set its value to true when begin play finishes execution. Return to the game mode, then create a function and name it f_check for controller's readiness. This function will check the status of each controller in the list. Loop through the list of controllers, then check the state of the isControllerReady variable of each element in the list. For now, I want to use a simple cast. If the condition is true, we must spawn the character. Copy the node spawn actor and paste it into this function. Now, a simple access to the game instance to get the player card of each controller. Now we have to do this check continuously. You can call the function on tick event. I prefer to use a timer instead, because I don't want to do the check for each frame. On event begin play, call the function setTimer by function name. Give this node the name of our function and check the loop box, then set a looping delay. Promote its output to variable, so we can reset the timer later. With this implementation, the function will spawn a character every 0.1 second, as long as the controller is ready. So we must specify not to spawn the character if it is already spawned. To do this, create a variable and name it spawned characters. It will be a map while the key is the controller, and the value is the spawned character. Now add a key value pair to this map after the spawn actor node. Now, before the spawn node, we must check that the map does not already have a key for the controller. That means, for this controller, there is no character spawned for the moment. Like this, each controller can only have one character spawned. Run a test to verify the implementation. There you go. As you can see, everything is working as it should. Again, I'm not a fan of cast. We'll replace it with a blueprint interface. Before proceeding, we must update the variables on post logout. So remove the controller from the list, then destroy the character, and finally update the map. Now I will create the blueprint interface of the lobby player controller. Follow me to do it. In this interface, we will add two functions for now. One function to get the game instance variable from the client, and another one to get the EOS controller ready variable. Return to the player controller to implement the interface. Now return to game mode to replace casts with interface functions. Run a test on an authenticated user. Here it is. Everything is working as it should. That's all for today. See you in the next one.